the closing of opening ceremony. After that, we will have a keynote presentation by our key speaker today, Mr. Champika Wijayatunga. Talking about Champika Wijayatunga, he is Regional Security, Stability and Resiliency Manager, Asia Pacific. He is the ICANN's Regional Security, Stability and Resiliency Engagement Manager for the Asia Pacific. He is a part of ICANN's Global Stakeholders Engagement and SSR team and represents ICANN in security, technical, law enforcement and capacity building forums in Asia Pacific region. Prior to ICANN, Champika held managerial specialist and liaison roles at the Asia Pacific Network Information Center, the Regional Internet Registry for the Asia Pacific. Champika started his career with IBM Corporation as a system engineer and later worked in IT industry, academia, research and training environment in the Asia Pacific. Champika received a number of excellence awards during his academic and professional careers and also served in various technical community groups and community. So we have Champika Wijayatunga here. I would like to request you all to give it a round of applause for him. We will have Champika Wijayatunga here now, and I would also like to request our organizer to please help him with the slides. Thank you so much.
But of course, DNS would not understand the different scripts, but we still have to convert those scripts into ASCII format, and that's what you see over there, an ASCII character set, and so that's basically an IDF. So you can see that all these different, over the last 30, 40 years or so, the domain name system, the DNS, has evolved quite a lot, especially the top level domains has increased up to currently over 1,500 or so, right, top level domains. And then we go to the next level, which is what we call the second level domains, and then the third level domains and so on. So for example, if you want to visit a website called www.example.com here, right, www.example.com. Basically, you wouldn't care about all these things when you type that in your browser, right? Or even probably you don't type anything, you might just open your mobile app, right? But actually, the client software or the client resolver that you have will have to do what we call a query, DNS query, based on this hierarchical structure to find where or what is the IP address of that particular web server. Because earlier we talked about these unique identifiers, behind these domain names, we have an IP address. We don't type IP addresses in your browser because as humans, we can't remember these IP addresses. If I ask you, there are many organizations here, if I ask you how many of you can remember your company web server IP address, not many people can remember that. But if I ask you, okay, what's your company website or the web server, then people can easily remember that. So that is why actually, we don't really, as humans, we don't really deal with IP addresses much. But as general users, humans, we can easily deal with the domain names, the names, right? We can easily remember that. So that is why the DNS will provide a mapping between these names and the numbers or the IP addresses. So that's why we have to put these domain names into a proper structure, like in this case, a hierarchical structure, properly delegated so that there is a proper structure behind DNS. So we have the root, the top level domains, the second level domains, third levels, and so on. And that's how the DNS structure is being built or designed. Now, one thing what is important for you to remember is that all those, say the TLDs or the second levels and so on, they keep a certain space, right? So if I take .com is a space or a database, or .net is a database or a space, .mp is a space or a database. And this database has to be kept in a server called DNS server. So that's what we generally refer as a DNS server. So these DNS servers, they keep these databases. Specifically to say that these servers are called authoritative servers because they are authorized to give reliable answers about these spaces. Okay, so now moving on. So how the DNS work, right? You can't see the title here, but the title says, okay, how DNS work. So in terms of, say for example, you have an end user over there, and that end user would type a domain name here, www.example.com. You are the client. So this query would go to what we call a recursive name server. So typically, these recursive name servers are maintained or managed by the service providers like ISPs. So if you are a user at home, most likely you will use your ISP's DNS recursive server. That's what sometimes we call it as a local DNS server. So your query will go from your device to your ISP's recursive server. In a corporate environment, sometimes the companies, banks, and so on, they may also decide to operate their own corporate recursive servers for their clients. That is also possible. Sometimes we use public DNS servers, public DNS recursive servers. There are various companies out there who provide these recursive name servers as a public service. So whatever the case, we use different kind of recursive name servers for us to do our DNS queries. So these DNS queries would go into these recursive name servers, and then the job of this recursive name server is to now find an answer to the client. So basically now client is asking, I want to visit www.example.com, which means the client needs actually the IP address of www.example.com, because if the client doesn't know the IP address, it cannot go to that web server and download the web page. So the client needs to know the IP address. So now the recursive server has got a job. The job is to find the IP address of www.example.com. So what the recursive name server do is, it will traverse through that tree hierarchy that I mentioned you before. So the query would go to the root servers, because root means root servers keep the root database or the root zone, and then the root would give a reference to the next level or the TLD level server, and then the TLD level server give a reference to the second level server. So in this case, root will give a reference to .com, and .com will give a reference to example.com. And when the recursive server goes and talks to the example.com server, example.com server can exactly provide the IP address of www.example.com. So that's how the recursive server gets the IP address of the web server and then return back to the client. So this is how a simple DNS query gets resolved. But now, the question is this secure? Right? So we do these queries all the time. Now the question is whether these queries are secure. Can you believe if this example.com gives the recursive server an IP address, okay, you go and visit this web server, can you believe that you receive the correct IP address? Because if you receive a wrong IP address, you may end up in going to a wrong place, right? And people can purposefully do this. There can be various security threats relate to this whole scenario. So that is why actually the whole purpose of DNS security is important in this regard. So if you specifically look into the components of the domain name system or DNS, you can see there are a number of components here. One thing, of course, our resolver, the client resolver itself. If you use a mobile phone or a laptop or any device, right, or even any IoT device for that matter. So these are all stub resolvers. So stub resolvers are built into these clients. And then we also have recursive resolvers, typically managed by the organizations that I mentioned before, like ISPs or public domain DNS servers, or even corporate DNS servers, and so on. And then also we have all those other authoritative servers that I mentioned before. Root servers are authoritative for the root zone, and .com servers are authoritative for .com zone, or .np servers are authoritative for .np zone. So these servers are actually called authoritative servers. So the queries, the recursive servers, that means they all go and talk to various of these authoritative servers and get the authoritative answers, and these answers are returned back to the client. So these are the main components that we see in the DNS. Now, if you see where we are vulnerable from a security point of view, so if you manage this DNS infrastructure, right, where can someone attack you, right? Where can you get attacked? Where are the risks involved? So these are the places that you have to protect, right? You have to be aware. Now, as you can see, actually, I put all those in red text just to say that these areas can be vulnerable, right? So this is why we have to pay special attention in terms of DNS security. So for example, the recursive resolvers or the recursive servers, they are the ones who are basically serving the client. So if the recursive servers or recursive resolver is being hijacked, right, then definitely there's a problem. These things can happen. For example, when we travel or when we are in public places, right, we use sometimes, if we see some free Wi-Fi hotspots and so on, we connect to those, right? So when we connect to those, that means we are using those infrastructure, right? So if we are in a public place, we connect to a hotspot, that means we are using that infrastructure. So our queries could be going to their DNS servers, right? But can you trust that, right? So these are the questions that we have to ask us, right? And so trust is very important in this whole DNS context. And these servers can be hijacked. Or one of the other problem is that these recursive servers, the caches means actually the answers that it keeps in the memory. These caches can be poisoned or polluted. So for example, now if I am a recursive server and you ask me, okay, give me www.example.com. So I will go out to authoritative servers, the root servers, TLD servers, and so on, and I will find you an answer. I will basically find the answer and give the answer to you, right? Because you are the one who is asking me that question. You are my client. So when I give you that question, the thing is that in case if someone has poisoned my cache, so if someone has managed to change that answer to something else, then there's a problem, because now I'm giving you a wrong answer, so a wrong IP address. So you're going to visit a web server, but by thinking that you are visiting the right website, but you may not be visiting the right website. You are visiting a wrong website. But actually, look and feel could be same. Maybe if it's a bank website, the look and feel could be the same. Maybe the web page looks same, but the IP address is different. You're going to a wrong place. So this is why actually these sort of issues are very serious, especially in terms of security. Cache poisoning, phishing attacks, and things like that are very common nowadays. Then there are lots of other security issues in terms of impersonations, DNS hijacking, right? So these things can happen. Even these authoritative servers, say for example, sometimes for better redundancy. We try to have multiple authoritative servers because in case if one server goes down, you have to have some redundancy. So you would try to have multiple authoritative servers so that in case if one server goes down, your whole domain will not go down, because otherwise if you only have one server, if that server goes down, if someone attacks that server, no one can get to your website, no one can send emails to you, and so on, right? So that's a big issue. So that is why we have to make sure that we have redundancy over there. So there are lots of issues to be considered, especially from a security point of view, and also impersonation should not happen as well. Because if these authoritative servers talk to each other, we have to make sure that they trust each other as well. If one authoritative server is talking to its other authoritative server, they have to have synchronization, they should be synchronized, they should be trusting each other, and so on. So there's a fair bit of security should be put into those contexts as well. So the whole idea what I want to give you here is that DNS is not secure until you secure it properly, right? If you just configure DNS, operationally it might work, the DNS queries might work properly. If you ask questions from DNS, you will get the answers, but as far as security is not there, it's not secure. So it is very important for us to spend time and try to actually consider these concepts and try to protect your DNS infrastructure. So I just want to actually highlight one of the key mechanisms that we use in this regard, which is what we call DNS Set. So DNS Set stands for DNS Security Extensions, right? That's the acronym for that, DNS Set. Now, with DNS Set, what we are trying to do is we are trying to protect our DNS data, because our DNS data lives inside our DNS databases or inside DNS servers basically. And also it lives inside those caching servers or resolvers that we discussed before, the recursive servers. So when we have DNS data in those places, in case if someone managed to change these data or pollute or poison this DNS data, we should be able to detect. So that is where DNS Set actually will help you in. So this is why DNS Set is an important security mechanism for us to consider in terms of protecting DNS data. If we can protect that, we can avoid those cache poisoning issues. If we can protect, if we can implement DNS Set, we can protect those DNS hijacking issues and so on. So it is a very important security mechanism. Now the whole concept behind DNS Set is, what we do is we digitally sign our DNS data. So you keep DNS data in all those DNS servers, right, in your databases. And what we do is we digitally sign those data. Probably you know about these cryptography, right? So in cryptography we use things like asymmetric keys, private keys and public keys. So what we try to do here is that we generate those keys, private keys and public keys, and we sign our zone data or the DNS data. And then we generate signatures, that is associated with this DNS data. And those signatures can be verified using our public keys. So that's the main concept behind DNS Set mechanism or the technology. Now, say for example in this case, if example.com want to protect its own zone or its own database or the DNS data, it can sign this example.com zone file and then propagate that trust, right? It is very important about the trust propagation, because always DNS is a hierarchical database. So what we do is then we propagate that trust to the upper level or the parent level. As we saw in the DNS hierarchy, we have the root, the TLDs, the next level domains, and so on. So if the second level domains has digitally signed its DNS data, it should always propagate that trust. In other words, the public keys or the hashes of those public keys to its parent zone, right? So in this example, example.com would propagate that trust to .com, and in the same way, .com would then sign its zone, the .com zone, and then propagate the trust to the root zone. Right? So that's how the trust would all the way go and end up in the root zone. So then, when the recursive service, when it does queries, right, recursive service stays in the middle, and when it does all the DNS queries, now it can validate whether we are getting the responses from the right party, the right servers, and also it can validate those signatures. So this will help us to achieve very two important security principles. One is the authenticity, right? Authenticity. That means, are we talking to the right party? Are we getting this information from the right place? And the other thing is integrity. Integrity means the data has not been tampered or changed. So this is where also, like in security, when we download software and so on, we check the checksums, right? So the same thing, to make sure the integrity is intact, it is there, right? So the same sort of principle here, by using those signatures, and we can make sure that the data has not been modified. So that is the basic concept behind DNS Set. So if I just try to compare without DNS Set and with DNS Set, so on your left-hand side, you will see without DNS Set. If a client is sending, okay, I want to visit my bank or myexamplebank.com, right? But always, there could be an attacker who could try to poison the caches or send some bogus responses to a recursive name server, and then the client would get that wrong IP address, which is shown in the orange color over there in the left side. So the client will get a wrong IP address, which means the client will visit the wrong website. So this could be basically a phishing site. So client would get to a wrong bank website instead of the correct bank website. But if on your right side, if you have deployed DNS Set, and if we can validate that whole chain, the hierarchy, the DNS hierarchical model, we can stop this thing, we can drop that query in the first place. When the, as soon as the recursive server gets the wrong response, it will drop that response. It will not give that response to a client. So in this way, the client will not get a wrong IP address. So this is just to get a comparison. If you deploy DNSSEC and if you do not deploy DNSSEC, what sort of difference that will get to the end user. Now, I also want to actually, before I finish my talk, just want to actually give you some statistics. These are all real statistics, right? So that you get a feel of what's happening there in the world in terms of DNSSEC deployment, so that you can also think about this to deploy in your networks. Now, globally, currently I told you that we have around 1,500 top-level domains. To be exact, around 1,543 top-level domains exist now, right? So this means like .coms, .net, .edu, .np, including everything, right? So the top-level domains, we have around 1,543. So out of that, 1,399 top-level domains, they have deployed DNSSEC, which means they have signed their top-level domain zones, right? 1,399 out of 1,543. So one thing to note, actually, specifically from Nepal's point of view, is .np is actually not within that 1,399. So this is something for you to consider actually in Nepal, right? So that means actually .np zone, .np domain has not been signed. So this is something that I think as a community in Nepal that you can possibly look into. So the top-level domain can be protected, right? And then, so currently around 90% of those TLDs, they have deployed DNSSEC and they have protected their zones. Going to the second level domain, currently about 4% of second level domains have deployed, not much comparing to that 90%. Second level domains is only about 4%, but 4% if you take as numbers, it is still very large because currently there are worldwide, currently there are like 400 million domains, second level domains. So if you take like 4% of like 400 million, still that's a big number. But if you still have second level domains, if you can deploy, we can bring those numbers even more than 4% of course. So this is again something for corporates to think about, for any second level domains to think about. So some statistically about countries, the CCTLDs that have deployed DNS Set here. So these are different stages. You can see that worldwide, of course, the orange shows the experimental stages. The yellow ones, they are sort of, they are announcing that they are going to deploy. And there are some partial deployments at the current. Now, the light green shows that the trust has been sent to the root. So the root zone, the root servers, they have received the trust from the top level domain. But the TLDs, those TLDs, they are not still accepting the trust from their second level domains. The last one, which is the dark green, that's all the production. They are everything, those country code top level domains are in production. That means they have deployed DNS Set, they are receiving the trust from their second levels, and so on. So this trust go all the way to the root. So this is all very good. So you can see actually now, you can figure out where this is something where Nepal is probably not, have to now work on, because we see that it is still white over there. White means actually it has not been deployed. So I hope that this will bring some interest here to think about DNS Set. So now finally, just before I end, I just want to think about a few takeaways out of this discussion that you have. If you are a company, corporate, think about signing your corporate domain. So if you are example.com or company.whatever, right? Think about digitally signing your DNS data, right? So which is very, very important from a security point of view. And also the validation. Now, validation is all done by the recursive server, especially for operators, ISPs. They are the ones who do the validations. So if you are an ISP, if you are running any recursive servers for your clients, make sure you make the validation on, right? So if you are a corporate, if you are trying to run your own recursive servers, try to enable the validations. Also, if you are managing your authoritative servers, try to sign your domain names. So this is important. If you are a generic user, if you are an end user, what you could do is ask your ISP, ask your provider that can you validate my queries. At least if there are some interest coming from the clients, this might enable the ISPs to validate DNS Set queries, right? So this is something that you could do if you are a client or if you are a user. In general, I think try to learn about these security mechanisms. There are plenty of training courses available out there. We work with community quite a lot actually. So we are very happy to even support you with capacity building. Even if in the future, if NP-CERT want to have some maybe some workshops, capacity building activities along DNS Set, we are very happy to come and do some hands-on workshops on how you can configure your servers and so on. So with that note, I think I just want to finish my talk, and I hope that it has given you some thoughts to think about from a security of DNS, and also to think about what are the important things that you can implement in terms of securing your DNS servers. Thank you very much, and if you have any questions. Time I can take now, otherwise I will be around, so feel free to talk to me and and I'm very happy to talk to you and answer any of your queries.
My queries is when we propagate trust or use trust propagation method, how the integrity is maintained.
Yeah, so now the question is about propagating the trust. Now, there's a fair bit of technicalities involved. Probably I can talk to you in more detail later, but conceptually if I tell you, see, the important things are here the public keys and the signatures, right? So the thing is that, say for example, I manage example.com. So what I would do is, so inside my database, inside my zone, I would be having various records like www.example.com or ftp.example.com. So these are all records or zone data that I would be having, right? So now the thing is, when a recursive server talks to me and get a response from me, I will say, okay, if the recursive server asks me, give me www.example.com, I will provide that resource record, right, including the IP address, because technically that's what we call a record, right? So this information goes to the recursive server. Now, to manage the integrity of these, as I mentioned to you before, we have to sign this data. So either you can incrementally sign your zone, or you can sign the whole zone, so that we can sign the resource record sets that are inside your zone. So that is one thing. Now the thing is that if I only give you this information, there's no other way that you can verify whether the information that I give you is correct. That's also why you said the propagation. Yes, the propagation has to be done from yourself to your parent, because parent is the one who delegated the zone to you. So if I have example.com, I got example.com domain from .com, because .com is the one who delegated me that. So this is why I have to send the trust, means my public keys, or in other way, hash of my public key, so that we don't have too much of overhead there. So this hash has to be then sent to my parent. So then what the parent, that means .com has to do is, they have to put that my trust or the hashes of my public keys into their zone, the .com zone, and then sign that zone so that any recursive server that talks .com, that can be verified, right? And then it doesn't stop there. The .com also now has to send their trust to the root. So those public keys of .com has to be sent to the root zone. And then root zone would again put that trust or the hashes of the public keys they get from .com will be put into the root zone, and then the root servers will basically have the root keys to sign those DNS data as well. So there is whole process about trust management of root keys. There's another big area as well in security. This is all about how we manage the root keys. And so this is how the integrity and the is actually maintained throughout this hierarchy. Okay, I hope that's a very quick answer, but I can talk to you later in terms of more detailed responses. All right, thank you very much.